It's fine. Welcome, everyone. It's great to see actually new faces in the room, and I think some of you were probably here yesterday at the Eclipse IoT working group meeting. Some of you were not, and well, today's our IoT day, so it's more about yesterday were sort of technical discussions between the different open source projects and how we can collaborate, etc. Today is more sharing success stories, case studies of how people are using Eclipse IoT. And yeah, as a way to kick off the day, a quick introduction to what's going on at Eclipse IoT in general, and maybe before that, taking a step back and where does Eclipse IoT belong? Well, the Eclipse Foundation, right? And I don't want to spoil. I think Mike later today, Mike Milinkovic will be doing a keynote on all things Eclipse. But just as a reminder, basically, Eclipse IoT is an open source community within the Eclipse Foundation, and the Eclipse Foundation is an open source organization that takes care of helping companies and individuals be successful with open source software. So we have literally hundreds of projects and members, and people on staff like myself and my colleagues. We help with projects be successful, open source communities be successful. You can think about open source as, oh well, I mean, I can go to GitHub, I can put my code on GitHub, or I can find code on GitHub. But when you start building commercial solutions on top of open source, you need some governance, right? You need someone somehow to help you with all the like the intellectual property management. You need someone to help you by providing you the resources that you actually require for working on the code and for collaborating. So I don't know, mailing lists and code repositories, bug trackers, etc., etc. And so that's essentially what the Eclipse Foundation provides. So we are a membership organization. Our members basically fund all the activities of the Eclipse Foundation, and among many others, of course, we do IoT, and you will hear about like many of the companies that are involved today. One of them is Bosch, and back 4 years ago, I think, they basically made the strategic decision that they would be building their IoT platform on top of open source, because for any company with a reasonable scale and size, connecting their devices to commercial solutions might not be the best thing to do. It lacks openness, it lacks flexibility, it lacks maybe you lack also the ownership of the data, of the actual roadmap also of the solution. So yeah, there's certainly a lot going on in IoT, and a lot means code. And you will hear today, like I guess half of the presentations will be around what technologies our companies and individuals building for helping people build their IoT applications, essentially. But beyond the technology, we also aim at helping, again, companies and individuals collaborate to be successful in their whatever is the commercial product they want to build, right? So what does it mean to promote the technology that's being developed? Why should we promote the technology? How should we do it in terms of, I mean, we have a wide variety of open source projects. How can people get started? How can they use the project? What are the typical use cases that we are enabling, and et cetera, et cetera. So that's really what Eclipse IoT is all about. We have well, certainly lots of code, and like historically, for the past, so we actually started Eclipse IoT in 2011. So for the first few years, we were aggressively, I would say, collecting projects and going out there asking people whether they would be interested in open sourcing such and such thing and piece of technology that they had. And as of today, I think we're pretty successful in that regard. We have literally millions of lines of code, 37, well, actually, it's going to be 39 real soon, and you will actually hear more about that today. I don't know if Paul is already arrived, but we have some really cool stuff coming. Lots of contributors, lots of people looking at what we do. Our websites are pretty useful resources for mainly for developers, but also for architects or for like people interested in learning more about what they can do with open source IoT. This is our member company, so we have 40. It's hard to keep up to date. I think it's actually 43 as of this morning. So it's always evolving, and I will spend some minutes telling you about what's the typical profiles, if you will, of the companies involved and why they basically join the ecosystem. You've seen this before, probably one way or the other. So our technology portfolio reflects what is still, at least in my mind, the typical IoT architecture, although there's certainly many definitions of what IoT is in the first place, many definitions of what a gateway is, what an edge device is, but in general, you often have your constrained devices / sensors, actuators that are like really close to that are the things, even I guess that you want to connect eventually to the Internet of Things. You have your gateways that help provide the connectivity and the edge computing capabilities, and then you have the cloud platform. In terms of constrained devices / things, this is not necessarily where the Eclipse IoT community is particularly strong, or at least focusing in terms of providing a full-blown stack / SDK for enabling people to build their devices. And there's lots of other open source communities out there that do it. You've heard about ARM Embed, you've heard about FreeRTOS / Amazon FreeRTOS, Contiki, Zephyr for really constrained battery-powered devices. So those are, if you will, real-time operating systems for IoT. Most of them, well, all of them are actually open source. Some of them are like vendor driven, like ARM Embed or Amazon FreeRTOS, but effectively they are, you could say that they are open source. They actually ship and come with some building blocks that come out of the Eclipse IoT ecosystem. So we don't do a lot of embedded, like constrained embedded software, but libraries like Eclipse PAHO, which you will hear a bit about today, or Eclipse Wakayama, respectively provide solutions for either like MQTT-based communications for like sensor communication, or solutions for device management. What does it mean to keep your device up to date so that like you can deploy new firmware upgrades over the air and things like that? Those operating systems basically reuse some of the stuff coming from Eclipse. On the gateway front, we have a more integrated story, and you've heard about Kura in the past, I think, at Eclipse IoT Days, or if you haven't, essentially think of Kura as a router, an internet router that you can program, right? So an internet router on steroids that knows how to connect and how to use connectivity mechanisms like Wi-Fi, like cellular, maybe like Bluetooth as well, or LoRa, and provides you with a way to put your own software within the gateway, so that you can start getting data maybe from Bluetooth, like using Bluetooth Low Energy, getting data from some wireless sensors, do some local processing at the gateway level, consolidate the data, do some signal processing, whatever, and then push the data to a cloud backend. So probably using MQTT, you will be sending your data to Azure IoT, to Oracle IoT Cloud, to IBM Watson, or maybe, to my point earlier, maybe you will also want to use an open source cloud, right? And we will get to that. But Kura is a very active project and very active community. It's based on Java, and it's pretty modular, so it's a nice platform. Eclipse SmartHome is also based on Java. It's a more specialized stack for home automation. So what does it mean to implement rules so that if the temperature in my bathroom is over a particular threshold, I want to send an SMS or things like that. So it's more consumer oriented, I guess, but it has like a really great ecosystem of individuals and also vendors that support Eclipse Smart Home. Deutsche Telekom, for example, or Orange, they actually use Eclipse Smart Home for providing home automation functionalities in DSL and cable boxes, right? That they sell. On the cloud front, what makes an IoT cloud specific? Like, of course, I mean, cloud is all about scalability and being able to ingest and manipulate huge amounts of data. So in that regard, I mean, there's nothing that's particularly IoT specific in terms of scaling in that regard. In terms of functionality, though, an IoT backend server, one of the functionalities that you're expecting is actually managing your devices, because sending temperature data to your to a server and like having nice charts and graphs and dashboards and mobile applications, it's not necessarily difficult. Like as soon as you have like a device that's sending data, you're good, right? But how do you keep the inventory, keep track of what are all the devices that you have in the field? How do you make sure that they remain up to date once you have started deploying thousands of smart thermostats? You want to make sure that the software they run stays up to date, right? So you need specific software for that, and we have really good stacks for all things device management at Eclipse. One is Eclipse Cockpit. So what does it mean to keep track of your device inventory? What does it mean to to keep in your backend server a representation of, okay, my devices in Germany, they are like 99% of them are running my firmware version 1.1, but I have 1% that's still running 0.9. So like getting this, managing this inventory, and then of course doing actual device management. For the 1% devices that are not up to date, I want to schedule an upgrade campaign so that over the course of the next 7 days, I will be rolling out new software. And I want Cockpit to be smart enough to do things like, okay, the 1% devices, it's actually 10,000 devices. So yes, it's going to take 7 days because one, I don't want to kill my network and my data center by having all the devices downloading everything at the same time. And two, I want to start progressively, and maybe like for the first hour, I will be just updating 10 or 20 devices. And if all of those devices report that, don't report basically that the update is successful, then it means that something's wrong, and I maybe want to cancel the upgrade campaign altogether, right? So all this logic, this orchestration logic, if you will, this is part of Cockpit. And with Leshan, you can have like a more specific implementation in terms of the actual protocol that you're going to use for managing the upgrade scenario and workflow using the lightweight M2M protocol. So that's what Leshan provides, and it's used by companies like Samsung, like Bosch, obviously, and CR Wireless. They use Leshan in production today. So device management is important. I think you will hear that often today. And other functionality that's kind of IoT specific and kind of like the microservices that you require for IoT, so device management with Leshan and Cockpit for sure. Hono. Hono is something that is pretty critical with IoT. There's lots of devices that you need to connect one way or the other. Some of them are, I would say, greenfield devices, so you have some flexibility in terms of what protocol you're going to use. You will likely decide to use MQTT or maybe an HTTP-based kind of protocol, but you have also brownfield devices, legacy devices that talk OPC UA, maybe weird variations of FTP-based transfers. So how do you ingest the data in your backend system so that your applications don't really need to care about how they should interact with the devices and have an abstraction of that complexity. So that's exactly what Hono is about. Deploy deploying protocol adapters at the edge of your data center so that you have MQTT endpoints, FTP endpoints, HTTP endpoints, whatever, for your devices to ingest telemetry in your backend, and the other way around for your applications to push commands to your devices. And of course, doing that in a secured way and in a scalable way. You will hear about Ono in the session right after next this morning. So Ono is another service that you need. Digital twin. I have devices that interact with my data center and with my applications, I guess, through Ono, but the devices are not necessarily always connected. So how do I keep a representation in my backend so that the applications can interact with a digital twin of my devices? That is, I have a smart thermostat that's not necessarily always connected. I want to use a server-side API to interact with a representation of the thermostat and maybe send commands that will be reflected on the digital twin and eventually on the actual device as soon as the device is connected, basically. So, long story short, you need there's several microservices that one needs to deploy in their data center for deploying a full-blown IoT platform. And I mentioned some of those services. Eclipse Kapua is the glue between them. Of course, you need some kind of federated API when it comes to interacting with your IoT platform, a federated dashboard, maybe, like in terms of user interface. So that's what Kapua is all about. So yeah, one thing that I mentioned earlier is that enough with the technology, I guess, and I think the rest of the day is going to be very much about the technology anyway, so you will hear more about Ono, about Kapua, etc., etc. In terms of ecosystem, like how do companies collaborate at Eclipse IoT? Why are they doing this in the first place? Why did companies like Bosch, like Samsung, Siemens, Intel decided to collaborate in open source? Well, for companies like Bosch and Siemens, who are very much about producing sensors and the actual the billions of things that you have in the Internet of Things, I think those companies account for many of them. Everything you would find in your car, in your dishwasher, in whatever. So they need to basically enable what we call Industry 4.0, like using Internet of Things, using the data that we collect from sensors to improve manufacturing, the actual manufacturing of the devices, to improve the kind of knowledge that we can extract from everything that we collect on the car or on a factory floor. And so for that to happen, there needs to be interoperability. Like, it sounds pretty naive to say that, but there are hundreds of partners and suppliers that are involved in the supply chain for a car or for anything really. So enabling interoperability, there's not so many ways to do that. Well, I mean, if you're a large enough company, you can impose some standards and some views, but it's even better when you actually collaborate in open source, so that anyone can really share their take on a particular like on architectural decisions, etc. And that's exactly what's happening with like the projects that Bosch, for example, are driving at Eclipse. Another important aspect is enabling people, and I guess companies like Bosch or Siemens, they eat their own dog food there, enabling people to run an IoT platform on premise. Like, for many different reasons, it's not always desirable to have a public cloud, basically, for IoT. So what does it mean to have microservices for like similar to what you will find in Azure IoT or wherever else, but that you can actually own and run in your own data center? Software vendors like Red Hat or Canonical or Influx Data, Contact Software, one way or the other, they build on top of the technology that's being developed within the Eclipse IoT ecosystem. So think MQTT libraries, think Eclipse SmartHome maybe, and they productize it one way or the other. Maybe they sell it and they distribute it as part of their distributions, if we're talking about companies like Red Hat or Canonical, or they build connectors, like think about it, like Influx Data or Contact Software. They have respectively database solutions or PLM solutions. They have connectors that will use and be compatible, if you will, with the Eclipse IoT technologies. So they want to promote their expertise, and they need to use Eclipse IoT as a way to showcase how they differentiate from the pure open source ecosystem. And so what is their value add? Well, they actually have ways to promote that in the Eclipse IoT ecosystem, and we very much encourage that. Of course, at our conferences, they can always come and talk and tell what it is that they're building, but we also have an initiative that we call the Testbeds. So essentially, for a particular use case, demonstrating how you can use a particular set of Eclipse open source projects and how they can complement basically commercial offerings, so that you can not only prototype by just using the open source stack, but you can also have commercial partners that will help you build a real, like a production-ready kind of solution. Hardware manufacturers like Sierra, Samsung, or Intel Eurotech that I mentioned previously. It's about device management, like providing a solution for their customers to be able to like effectively manage firmware over the air, and like deploy new firmware and software upgrades. So interoperability is key there. So for a company like Sierra Wireless, they sell modules, cellular modules. They don't want to tell they want to be able to tell their customer, hey, right now we provide you with a platform, with a solution for you to manage your devices over the air. But if 10 years from now we're out of business, or you want to use a different platform, a different cloud to manage your edge devices, it's fine, you can do it. It's not only based on an open standard, lightweight M2M, but our stack is based on Eclipse Leshan, Eclipse Wakayama, so you can connect our devices to whichever platform you'd like, right? Telcos, I mentioned Deutsche Telekom and Orange before. They're pretty big in the smart home space, and so interoperability in the smart home space is important by definition. There's just so many devices that need to be supported. So they collaborate in particular in the Eclipse Smart Home project, and they also care about the 1M2M standard for cloud interoperability, and for possibly like exchanging information between across different telcos. Services companies that provide all kinds of supports and services in terms of helping people with trainings and with support around the Eclipse IoT technologies. We do lots of research projects as well. Some of you in the room come from this background. So essentially helping research projects with the dissemination of their results. Like there's lots of pretty successful European or like any research projects really that are successful, that have great results, but the results just disappear at the end of the project. Should they have created some code? Well, the code lives somewhere in a forge that's pretty like invisible for the mere mortals. So with the Eclipse Foundation and with Eclipse IoT, we help such projects and we encourage them to open source the results of their efforts, and they basically turn into Eclipse IoT projects, and people can reuse the stuff. So wrapping things up with, again, moving away, I guess, from the technology, and giving you all some insight into ways to engage, also basically ways to learn more. Like we do a lot of education, and for those of you who've been coming to the Eclipse IoT Day for several years, you know about some of those initiatives. We have a virtual IoT meetup, for example. So this is essentially webinars. Every 2 or 3 weeks, we have webinars with industry experts, and typically about Eclipse and open source projects, but not necessarily. And we think it's important to have these kind of discussions so that we agree as an industry, I guess, on what are the standards that matters, what are what are the typical architectures that people see, and have these kind of discussions going. Open IoT Challenge is an initiative. I think we are, we're just launching actually this week the 5th edition of the IoT Challenge. What is it? It's a bunch of, like some of our member companies, our companies sponsor and give some money so that we have a pretty nice prize pool. Actually, I think it's like a few $1,000s for the winners. What do people need to do? It's pretty open bar, I would say. It's create a cool, innovative IoT solution using open source software. And so between now, like essentially, like I said, we are launching today. Between now and February next year, people will need to use Eclipse software or any open source software really to build their projects, and we ask them to really engage and to be very vocal about what they are building. So they are basically producing lots of tutorials and lots of blog posts about their journey, and it's really good feedback for the project. It's really good feedback for the companies that are actually sponsoring the open source projects, because they know whether the projects are actually useful, what kind of use cases people are using them for. So yeah, you should. We will be circulating the link, and we will be tweeting about the Open IoT Challenge a bit this week. But yeah, you may want to encourage people in your respective communities, companies, circles to participate. We ran a developer survey. This is something we've been doing also for several years. It's a way to learn more about what people do, and this is also a way for our members to get some insight into like whether what they do matters, whether the kind of technology standards they are supporting seems to actually be taking off or not. So if you are kind of a reminder to you all, if you are from a company, from a member company, keep in mind that we want you to get involved in the process of defining what are the questions that we want to ask people, etc., etc. And then testbeds. So I mentioned the testbeds. I guess the second row is more about how can companies get beyond collaborating on open source software, what kind of value they can get from a commercial perspective. So we have the marketplace, for example, the Eclipse marketplace, where companies can promote plugins, extensions to Eclipse Kura, to Eclipse SmartHome, all kinds of services that they sell, they have on top of Eclipse IoT. We are trying to work towards making it easier for people to consume Eclipse IoT software in the form of maybe some kind of simultaneous release or some kind of package that's more readily available. And yeah, the testbeds, you've heard about that in the past. If you at least last year, if you were here, how can we demonstrate? And this is a way. This is, I guess, my call to action to anyone in the room. This is a way for anyone to get involved. You don't have to work directly on an Eclipse project to get involved in the testbeds. It's more, I have a use case where I'm already or I'm considering using Eclipse IoT software, and I can't really build the solution alone. Like, it's very unlikely that you will be, if you're a FedEx or a UPS and you are interested in monitoring where the parcels are so that you can tell your customers, here's where the parcels are, etc., etc. It's very unlikely that you will be building the whole thing alone. You will have partners. You will have companies like maybe Samsung or Eurotech providing you with the gateways. You will have maybe Red Hat providing you with the middleware, etc. And but yet you will likely, one way or the other, you will be building on top of open source software. So helping people build and implement an end-to-end solution on top of open source software, and helping people demonstrate what they've achieved and why you should talk to them, basically, if you're interested in building something similar, is what we do with the testbeds. And we document basically the blueprint, the sort of the reference architecture for each particular use case. We document all the all the reference implementation, all the code that's been developed for the proof of concept, if you will, is also available. And yeah, we would like to encourage more companies to build testbeds at Eclipse. And wrapping things up, last slide, there's more, and I think eventually, in the next few months, we will probably end up wanting to rethink the way we approach IoT in terms of at least the three stacks, right? Devices, gateways, and cloud, because there's certainly a lot going on in the edge/fog computing space, and the line between edge/gateways, I guess, and cloud is becoming more and more blurry for at least for some people and some players. Typically, as soon as you start containerizing your IoT business logic, it might not matter that much where you run it, and more importantly, it actually matters to be able to run it independently at the edge or in the cloud, because you may want to be smart in the way you use your resources, right? And if you have a very efficient image recognition algorithm, well, it needs an image in the first place. So does it really make sense to upload megabytes worth of images to your cloud and have the algorithm run there? Or do you have enough processing power at the edge so that you can actually do just the same there? And maybe depending on your network topology, depending on the hardware capabilities of your devices, you want your fog computing agents and orchestration layer to take care of basically deploying and orchestrating all your containers, right? So Eclipse Fog OS is one such project that aims at enabling fog computing. There's a lot going on. Like there's certainly lots of consolidation in terms of IoT standards, but there's some emerging, I guess, standards still, and in the industrial IoT space, DDS or Sparkplug are something that you may want to have a look at if you're from that particular background. The W3C is working on Web of Things and making the good old web/REST paradigm suitable for constrained network and constrained devices. And yeah, there's also like not necessarily purely IoT and necessarily IoT specific, but in terms of machine learning, you may not know that, but we have a really cool alternative, I guess, to things like TensorFlow, especially if you come from an enterprise Java background. Eclipse Deep Learning for J is basically state-of-the-art machine learning and AI for yeah, that can be applied for IoT and maybe for like language processing if you're interested in like maybe voice recognition or that kind of stuff. So you may want to check that out. And with that, yeah. Wrong slide. That was kind of a backup slide for people interested in the results of the IoT Developer Survey. That's what I had as a way, and it's good because I'm now losing my voice. That's what I had as a way to kick off the day. We may have room for half a question if you'd like. No, seriously, if there's questions, let me know, and thank you.